In today's lesson, we are going to work on graphing sine and cosine functions. But before that, we're going to do a little bit of review with just sine and cosine itself, and then also come back and look at the unit circle. So here's 3 warm-up questions. So what I would like you to do is for these first 2, find both of the sides, and then for this last one, find the last side, and then also the angle. So pause and do that, please. So when I'm trying to find this side, I'm just going to call this W. So when I'm trying to find side W, according to this angle, this is adjacent. So adjacent hypotenuse uses cosine. So the cosine of 32 degrees equals adjacent over hypotenuse. Now, hopefully some of you just realized, well, hey, this hypotenuse is 1. Cosine is the angle, the side that's attached to it. And this is kind of set up like your unit circle purposely as well. So therefore, because it's over 1, the cosine of 32 degrees is just W. And you just type that into your calculator. When you type that into your calculator, you end up with 0.848. And then if I want this side, we'll call this D. In order to find D, this is opposite and hypotenuse. Opposite is sine, and since the hypotenuse is 1, just the sine of 32 degrees equals D. Therefore, D is just, typing that into my calculator, 0.53. So therefore, this side here is 0.53. This side here is 0.848. Okay, so now I've got this triangle, and same type of situation. So hopefully when you did this already, what you came up with is, so this is 58 degrees. This is adjacent to it, so therefore the cosine of 58 degrees equals, call this Z, Z over 1. Therefore, when I type in the cosine of 58 degrees, the cosine of 58 degrees is 0.53. But then when I want to find this side, I'll call this side C. So that's opposite, so therefore the sine of 58 degrees equals C over 1, which is just C. So therefore, typing that into my calculator, hopefully you kind of saw a pattern, 0.848. Maybe you didn't. But what you should realize is 0.848 is here, 0.848 is here, 0.53 is here, 0.53 is here. These angles are complementary. For this one here, the 0.53, that was the sine of the angle. This one is the cosine of the angle. But because when we're looking at complementary angles, my sine and cosine switch because I'm looking at the other angle. Same exact thing happens in the unit circle. If I looked at the sine of 30 degrees, that's exactly the same thing as the cosine of its complementary angle, which is 60 degrees. So there are those patterns that will happen within those complementary angles. Okay, and then the last one is just a regular measurement. So one of the things that you could look at, okay, so this horizontal is the square root of 3 over 2. The vertical is a half. So if we looked at this, putting it on the unit circle, the x value is the square root of 3 over 2. The y value is a half. So over here, square root of 3 over 2 a half. That would be 30 degrees, which is also pi over 6. And we're going to do both radians and degrees. The higher up in math you go, the more radians you work with. So, and then also, you could do the Pythagorean theorem to find this side. Leg squared plus leg squared equals hypotenuse squared. Or you can realize this has to be a unit circle, and that is a length of 1. So, just a couple of things to look at. We use theta, remember, when we're dealing with angle measurements. We can also use x's and y's, though, too. Okay, so now we're going to get into the graphing of sine and cosine. We're just trying to get you as comfortable as possible looking at side lengths, understanding that sine is just your opposite over your hypotenuse. So that's part of why your sine value is always your y. Because if you look at this right angle here that this made, this right triangle, this is your opposite side and your hypotenuse is 1. That's why the sine of your angle is the height. Whereas the cosine of your angle, that's adjacent. Well, this side is adjacent, and it's adjacent over 1. So that's why the first one is always your cosine, the second one is always your sine. If you need to, write your coordinate point out so you know which one's which. Cosine theta is your x, sine of theta is your y. And then remember tangent to theta, which we're not going to do a lot of work here with. You'll do this a lot more in pre-calc. Tangent to theta is just the sine of theta over the cosine of theta. Okay, so just all the different relationships with what we have. So in graphing the sine of theta and the cosine of theta, we have to know what our unit circle looks like, because you're not going to have your calculator when you're doing these transformations. So you are going to be graphing the parent function, which is what we're going to work on today, and then you're going to add in the transformations, which is what we're going to work on tomorrow. So we're going to start with the sine of theta. So we are going to graph y equals the sine of theta. So what we have here is we have this unit circle, and it's representing the heights. So these are all my heights at each of these angle measurements. And we have them broken all the way down into 15-degree measurements. Please know, you do not have to do 15-degree measurements. You're not going to have those memorized. We're going to work with 30s, 45s, 60s, etc. So you're going to look at the angle with 30 degrees. You're going to look at the angle with 45 degrees. You're going to look at the angle with 60 degrees, 0, 1, and then you're going to keep going around. You're going to go another 30 past 90, so that's 120. You're going to go 45 past 90, and you're going to keep doing each of those measurements. So we're going to be graphing all the way around. Okay, all the way to 360, and then also remembering that we can go negatively as well, because if I go this way, remember that's a negative measurement, so I can also go on the left, and we'll do that with our parent functions too. But what we're going to look at is we are looking at, if we're doing sine, sine is the height. So that height there at 30. So this height here, if I were to draw a horizontal line from that height over, I know at 30 degrees, which is right here, it is that height. Okay. Now I can take that line away, and now I can look at another line. This is going to get kind of messy. Then I can look at another line at 45 degrees, so I'm just going up at that height. And then at 45 degrees, so that's right here, it's this height. And then I can do the same thing at 60, because again, all I'm doing is the x value is my angle measurement. The y value is the height, since sine is your height. The sine of your angle is your height. So therefore, at 60 degrees, that's right here, that's up here at this height. And then at 90 degrees, well, that's height of 1. And let's not forget 0. At 0, it's 0, right? The height at 0 is 0. And then I can keep going past. So in order to go past, it might make it easier to draw in those reference triangles. Remember, the reference triangle is the angle it makes with the x-axis. So therefore, I drew in my reference triangle. So this height over here, if I were to extend this line, so at this angle measurement, which is 30 degrees short of 180, so that's at 150. So again, 30 degrees short of 180 is right here. Let's draw my pointer, sorry. So here's 150, so that has a height here. And then I can keep doing that. I can flip this triangle upside down. That blue point is off a little bit. And then, so this here, I can draw a line from there over. And now I can plot that point. So this is 30 degrees past 180, so that's 210. So right there is this point. And I can put all of those different points on my graph based on doing the whole reflection. Going all the way around, I know back over here at 360, my height is 0. So what I want you to do is I want you to picture each of these individual points along the way and see if you can get that nice curve. So here it is all filled in. What I did is I just brought those heights, I dropped those heights down, and then I brought over my horizontal, so to get that nice smooth curve. Please keep in mind, it is all of these values along the way, so therefore we must connect the dots to the best of our ability. And it keeps going both directions, right? We talked about negatively, so if we went negatively, so negative 30 would be here, so negative 30 would be right there, and then it would keep going. Okay? So that's graphing the sine. Again, the sine is that height. Cosine is not the height. Cosine is the adjacent side. So what we're doing is we're graphing that horizontal length for a 30-degree measurement. So therefore at 30 degrees, it's this length. Now, what we have to do is we have to take this length and go this way with it, which can be hard. But if you remember with complementary angles, this horizontal is the same as whose vertical? 60's, right? So therefore, if I drew out that line from 60, that vertical is the horizontal at 30. That's the base. So we get that. So you're looking at switching each of those pieces. So I have something here. So this horizontal here at, let's bring it in just a smidge, 30, we take and we rotate it vertically. So that's my 30 degree. Come on. So that is where my 30-degree marker is. And then I can do my 45, which is actually kind of nice because 45, what do you notice about the horizontal and vertical of 45? It's the same, right? The horizontal, 45, 45, 90, those two angles are the same. Okay, so I can't graph that one. I can't grab it. But what I do know is it's right about here for 45. Well, what's your height at 0? 0 is at 1. And then we can keep going. And when we keep going with this, we go through all of them. What do you know once you get past 90? Horizontally, what happens here? What kind of values are these? Negative. So at 90, your horizontal is 0, and then past 90, they're going to be negative. So they're going to be negative in this quadrant and in this quadrant. So they're going to be below the x-axis here. But then once we get to 270, we know that's going to be 0 again, because that's our horizontal distance. Back over here at 360, that's going to be back up here at 1. And again, we have this negative piece down here, so we get something that looks like that. Something that looks like that, which is our cosine graph. Again, just looking at each of those, remembering the complementary piece to it. So those are our sine and cosine graphs. So again, just a visual as to how these actually work. Now, we can look at the comparison between the two. Sine and cosine look very similar, and especially if we keep going with these past. So this keeps coming, it keeps repeating itself. And the same thing here. This one keeps coming this way. It keeps repeating itself as well. So what we can look at, though, is this one is y equals a sine of theta. This has a y-intercept at 0, 0. This one has a y-intercept at 0, 1. If I take this graph and just put it on top of this other one, okay, right? So now sine and cosine are both graphed individually. If I take this and shift it, we're all about shifts, right? So if I shift this, what happens? It's the same. Cosine is just a horizontal transformation of sine. It's just a shift. So what we're going to do is we'll be able to graph sine and cosine, and then when we write equations, we could actually write either equation because all the differences is a horizontal shift. But the important part is that y-intercept. It is the most important point to get you to graph sine and cosine correctly. So we know that sine of theta, if we look at my y-intercept, that's this value right here, this coordinate point is 1, 0. So therefore, when x is 0, the sine of 0 is 0, and the cosine of 0 is 1. So that y-intercept point is going to be the point that you're going to, in essence, start with. So a lot of times you'll hear people say it's the starting point. It's not the starting point. It goes in both directions. But you're looking at what is that value. Because now what you're going to do is based off of knowing your graph, knowing your unit circle, and using the easiest points possible, you are going to graph one cycle for sine and one cycle for cosine. These are nice points. I mean, we know how to find these. We could graph them. That's what we did here to get these really nice graphs. But we're going to look at those key, easy points for graphing, which are all the quadrilateral angles. So they're all the ones that are on the x and y axes. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And the ones in between are helpful. You'll need them when you get to tangent, but for sine and cosine, you won't be graphing those. So just keeping in mind these filled in points. So this is what you're going to get. You're going to get a blank graph, and we're going to say graph it. Well, what that means is you're going to have to scale it. Because remember, if you don't list the scaling, it's automatically assumed that you count by ones. So if you're going to graph this, your x-axis is not going to count by ones. We are counting by radian and degree measurements. We're counting at 0 degrees, 90 degrees, 180 degrees. Or we're going to be looking at 0 degrees, 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians. Remember at pi and a half, 1.5 times around the circle, and 2 pi radians. So keeping in mind that we're going to be looking at both degree measurements and radian measurements. Okay, so you have to mark your scale up. So for this, let's just do degrees just for ease right now. It's completely up to you. But typically it makes sense to count by 30 degrees or pi over 6 radians or 45 degrees, which is pi over 2 radians. Now we can break it down even smaller. We can do 15 degree measurements, which are pi over 12 radians. It just kind of depends on the problem. So first time here graphing, we are going to count by 30 degrees. So 30 degrees, 60 degrees, 90 degrees, 120. So I counted by 30 degrees, but I marked typically every 90 degrees. Okay, and then vertically, it completely depends how you want to do it. Remember, when we're working on a unit circle, there's no transformations, there's no vertical stretches. The highest point I'm going to get is at 1. The lowest point I'm going to get at is negative 1. So when you do your scale, you could count by quarters if you want. You could count by 1 just so that you can get an idea of it. I'm going to count by quarters. So therefore, this is at 1. This is at negative 1. And again, I'm just going to do that so that you can see it nicely spread out. So now when you use your unit circle, you can graph each of the pieces. So because we are doing sine again, remember, sine is the y value. So sine is your height. So knowing that 0.10, so this is what I typically do, because I will also mess up which one's your x, which one's your y. I mean, I know this, but I'll flip these 2 points around. So when I graph the sine, again, it is that y value. So at 0, it's at 0. And then at 90 degrees, it's at 1. At 180 degrees, it's at 0. At 270 degrees, it's at negative 1. At 360 degrees, it's at 0. That's one cycle for y equals the sine of x. I can go negatively, I can go this way. So negative 90 degrees is right here. So that's negative 1. So at negative 90, it's negative 1. At negative 180, it's at 0. At negative 270, it's at 1. At negative 360, it's at 0. And you should see a nice pattern that happens. So nice 2 cycles here. This is just your 1 cycle. But we can do more than 1 for sure. And what you're going to get used to is when you graph sine, you're going to see there are these 3 midlines. Midlines is halfway between. And then you have a max value, and then you have a min value. So for the sine, 1 cycle, that's typically what you're going to look at. Midline, 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 max, min. And everything is halfway. Every single thing is halfway, which also helps with that. So if I know it starts here, ends here, halfway's here, halfway's here, halfway's here. Now we're going to do cosine. With cosine, we're going to do radians because that's actually how you're going to be graphing these. You will not be typically using degrees, and part of that's because they just start to get so big, and when we start to do measurements, they get so large. So therefore, you have to get used to counting with your radian measurement. So if you're counting by pi over 6, you literally have to count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, etc. So when you count by pi over 6, this is 1 pi over 6, 2 pi over 6, 3 pi over 6. This is pi over 2, which again is that 90-degree measurement. 4 pi over 6, 5 pi over 6, 6 pi over 6. 7 pi over 6, 8 pi over 6, 9 pi over 6 simplifies. 10 pi over 6, 11 pi over 6, 12 pi over 6. And then we can also go negatively. If we wanted to count by pi over 4, we wanted to count by 45-degree measurements. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and etc. So it just depends upon what you have, especially for shifts. Now for cosine, again, think about that unit circle. We're looking at that coordinate point. That coordinate point is 1, 0. Cosine are your adjacent sides. So those are the x's. So think about what the x's are here. How far over? So this is 0. This is negative 1. This is 0. And again, this is 1. So when I graph this, here, I'll do quarters again. So this is 1. This is negative 1. So when I do cosine, we have cosine of 0 is 1. So this has a y-intercept at its max. And then here at pi over 2, that's at 0. At pi, it's at negative 1. At 3 pi over 2 is at 0. And at 2 pi, it's back at 1. So for cosine, it has a y-intercept at its max. 1 cycle later, it's at its max. Halfway between your two max values is at your min value. Halfway between your max and your min is your midline. And halfway between your min and your max is your midline. So we get this nice, like U shape in essence. And then we can keep going backwards again. So I know it's 2 pi is where it's going to cycle at. Halfway between those is my min. I'm going to eyeball it. I think it's right there. Halfway is your midline. Halfway is your midline. So that's 2 full cycles, if I approximated those correctly. And then we get our cosine. And then we can keep coming. Again, 1 cycle is from the min to min. 1 cycle is from the max to max, or midline to 2 midlines. And that's what sine is. So it's midline to 2 midlines is what 1 length is. Okay, so that's how you graph your parent functions for sine and cosine. You are going to get into transformations with those next.